Good afternoon, everyone. Thank you all for coming and thank you for being here. We're happy to have Dr. Kerry Houlahan from True North Genetics presenting for us today. Dr. Kerry Houlahan is Director of Genetics, Research and Development at True North Genetics, where she leads genomic evaluation and breeding strategies for commercial swine populations. She earned her PhD in animal breeding and genetics from the University of Guelph, specializing in quantitative genetics and genomic selection. Dr. Houlahan's work bridges foundational genetic research and real-world production systems, integrating complex genomic data into practical breeding objectives that drive efficiency, meat quality, and long-term system sustainability. Thank you, Dr. Houlahan, for being here today. You can take it from me.
Perfect. Well, thank you so much for the introduction. As was said, it's kind of nice to be back. I haven't been back in a while. So I graduated 5 years ago from CGIL. And what wasn't mentioned is I also got my master's and my undergrad here. So I'm a longtime Guelph grad, and it's really exciting to be back and to get to talk to you guys from what's the other side, outside of academia. So I always joke, my job is to make bacon taste better. So I thought I would talk to you about how we go from the breeding all the way to kind of the bacon on the plate and what the science behind that system is from an industry perspective. Because I remember being in academia, I always knew I wanted to come into industry, and I didn't really understand what that looked like outside of the dairy industry because that was my background. So I thought something a little bit different. Most of you probably work in dairy cattle, I'm assuming. So it kind of is going to give you hopefully a little bit of a taste of a different industry and sort of what we do. So first, I'm going to introduce you to True North Genetics. We are not necessarily a new company, but a new name. Previously, our company was known as Genesis, which if you're familiar with the pork industry, you'll probably know them. In 2024, Genesis was bought, and then later last year, our name got changed. And so True North Genetics sort of has now two pillars within the company. One is still sort of that Genesis genetics line, where we focus on genetic improvement, looking at selling breeding stock and offering genetic services to clients around the world. And then the other side of it is the Jersey Red Duroc pork product. And this is our exclusive pork product, as I said, and it sort of is known for delivering exceptional quality, flavor, and a better eating experience than kind of the general pork that you find in the grocery store. I'm mostly going to talk to you about the genetic side today, but if there's time at the end and you guys want to ask questions about the other side of the business, I'm happy to talk about that as well. I am going to start with talking a little bit about how swine breeding programs are structured. It's very, very different from the dairy industry. This was the biggest challenge I had to learn when I switched. And so I always like to give a bit of a refresher. So we work in a pyramid system. All of our stuff we do in the genetic component is done in the nucleus. This is where our main genetic lines are housed. This is where all the genetic selection happens, all the data recording, that kind of stuff. Some people will be familiar with the term great-grandparent lines. That's what lives there. From that, we move females and our maternal line males down to multiplication. This is where we create the F1 female or crossbred female that ultimately is going to become the mom of our commercial production. So commercial production, that's what you guys are going to end up eating on your plates, is that three-way cross. And that's a cross between our F1 female and our Duroc boar. And we'll get into the breeds. But pretty much everything I'm going to talk about is what's in the blue circle. I have a couple little research projects we'll talk about on commercial pigs at the very end, but everything that you see for the majority of the presentation is going to be focusing on that nucleus level selection because that's where it all happens. So we have three lines that we deal with. Our lines are exclusively purebred. It's something that's pretty unique. There has not been any introduction of a new breed for something like 50 generations. So we are exclusively purebred lines. As I said, there's three of them. We have two maternal lines, our Yorkshire and our Landrace, and then one terminal line, which is our Jersey Red Duroc. So the maternal lines are kind of known for things like mothering ability, reproductive efficiency, things like having lots of babies, being a good mom, producing a lot of milk, raising a lot of babies, that kind of stuff. And then they're also known for having uniform litters and then longevity. So something that's really important in the swine industry is we want to see sows that can have 5, 6, 7, up to 12, 13 parities. We want to keep them in our production herd for a long time. So that's something that we really focus on in our breeding program. It's hard in a nucleus. We don't keep pigs for more than 2 parities, right? We want constant genetic turnover, but in a production system further down, these pigs need to last for a long, long time. So things like structure, feet, and legs is very important. Then on our terminal side, this pretty much focuses on lean growth, feed efficiency, and then we look at carcass quality. So heavily, heavily marbled carcass. Our Duroc sort of is known, if you want high quality meat, this is what you're gonna get. It's kind of head and tails above everybody else. This exact line has been selected for about 35 years exclusively on meat quality. It's something that's pretty unique. Back when, probably in the early 2000s, when everyone said, fat's bad for you, a lot of companies essentially eroded the fat out of their pork, which is why what you see today is a very lean product. This company didn't do that. They ended up keeping a lot of the fat in the pork, so it is a slightly fattier pig, but it grows unbelievably fast. It's got very good feed conversion, which is really good from a production side, but also from a consumer side. You probably don't want something that tastes like cardboard when you eat it, and that's where this breed comes in. So that's a bit about the three breeds that you're going to hear about for the rest of the talk. I'm also going to introduce you to our genetics team. We are a small but mighty team. So you've already been introduced to me. We also have Dr. Erin Massender, who's here today as well. She's our geneticist. She also holds a PhD from the University of Guelph, and we both graduated from here around the same time. And then we have a genetic technician, Cassandra. She is on farm in Winnipeg on our main farms, and she is responsible for pretty much all the data collection that I'm going to talk about. She does all of our data entry. She supervises all the data collection on the farms, and it's a huge, huge integral role. Without her, none of this would happen. We're also very lucky that we work with a couple consultants. Some people will be familiar with Dr. Bob Kemp. He was my original boss and sort of my predecessor in the role. He's since retired and now works with us on a consulting basis, which is great. And then we have an IT consultant as well. And we're pretty lucky to have research partners from across North America, really. We work with people with Agriculture and Agri-Foods Canada, Iowa State University, Dalhousie University, and my shameless plug would be we're also always looking for new research partners. So if there's other people looking for projects in the pork world, please contact me. But like I said, small but mighty team, which you'll see as we go through all the stuff that gets done sort of on a week-to-week basis. As a company, our priorities kind of fall under three main spots. We believe that consumers desire an exceptional eating experience. Nobody wants something that tastes bad on their plate. You're not going to buy it. You're not going to eat it. So we think that pork quality is very important. Generally, pork is not sought after in North America, right? It's not the first thing you grab. You're going to go for a steak or something better tasting. We want to change that. And we also believe that this is a driver of income growth as we move forward in the future, as people get more disposable income, as other countries come higher up in their economic status. This is somewhere where we can grow. We look at having a competitive cost of production. That does not mean that our pigs are the lowest cost of production, but they will be profitable. So we look at profitability of the system over production costs as a whole. And then we also take a lot of time looking at feed intake. It's very, very important, and it's more than just your post-weaning growth efficiency. So most people will look at feed intake and growth from sort of weaning until about slaughter weight. We look at it through all stages, lactation, gestation, all of that, because ultimately what we want is a pig that's uniform, that can grow well, but also one that's able to milk really well. If they don't eat really well in lactation, they're not going to produce a lot of milk. So we look at it as a whole system as opposed to just a growth perspective. And I'm also going to talk about health. This is not something I was very familiar with being from the dairy world, which will surprise maybe a few people. But health policies on pig farms are crazy. It's nobody in, nobody out kind of idea. So health is extremely important. And this is because our lines are only housed in a handful of farms and nobody's allowed to bring in a disease. So our nucleus units are what we consider high health. There is strict rules when you come in terms of how you can shower, what you can bring and you can't bring, and how often you can visit a pig farm before you can come in. And that will vary on companies. Every company policy is a little bit different. And then what you wear when you're in the barn versus when you're in an office, et cetera. That's all very highly monitored. And then we have a vet team that comes in once a week, does blood tests, tests for diseases, all that kind of stuff. So it's very important. The other way that we manage disease and also preserving genetics is that we have dispersed and duplicated nucleuses. Essentially, that means every single breed is at a minimum of 2 sites that are geographically separated. So right now, that means we have sites outside of Winnipeg and we have sites in the United States. So completely geographically separated. That is for not just disease control, but also if anything, a natural disaster happened and those pigs died, we have the genetics somewhere else. We can keep going. You don't just lose, 40 plus years of progress. And the way that we make sure that all these herds stay genetically connected is we share semen, and sometimes we do import pigs back and forth so that everybody is still on the same program. We also have the same team of geneticists. As you see, it's Aaron and myself. We are the ones running the genetic program for those farms. And so it's done in a very methodical way to ensure that kind of everybody has the same genetic progress year over year. Nobody's too different from each other. So that's a little bit about the company. I'm going to talk about data collection, and while I take a drink, you can look at all the cute little pictures of the pigs and some of the things that we do. So the data collection I want to go through is going to stem from birth all the way to the carcass at the very end. We break it up into sort of 3 groups: birth to weaning, weaning to end of test or a performance testing side, and then a carcass and pork quality. And I'm going to talk a little bit about what we record and why we record it. So from birth to weaning, this is essentially the first 21 days of a pig's life. We record sort of some standard things like breeding records. We need to know who mom and dad are, right? We will look at things like litter size. That's a big number in the world of pigs in terms of how good of a mom is she, is how many babies does she have. We look at things like piglet survival. That's also really big. We need to make sure that everybody's alive, or as many can live as possible. I always talk about, it's nice to push up your total number born, but if they all die, it doesn't really matter. So we want to make sure that we're also getting a high number of pigs surviving. A few things that are a little bit more specific to a nucleus herd and specifically to our company is we look a lot at sow efficiency and lactation. So we take not only weights, but we also ultrasound her for back fat and her muscle depth, her loin depth, before she goes into farrow and after weaning. And essentially what that's looking at is her body reserves. How much of her own body is she using to produce milk for those pigs? We combine that with her feed intake, and then how much weight did the pigs gain between birth and weaning. So we take birth weights and weaning weights on her babies. And that all together kind of gives a picture of how good of a mom is she. How much milk can she produce? Because unlike dairy cattle, I don't know if you've ever tried to milk a pig, but it doesn't go great. I have tried. Doesn't go great. So we can't actually measure her milk production, right? We have to measure her baby's growth as sort of a prerequisite for what her milk production actually is to know if she can handle raising a lot of babies. That's really, really important. That goes along with, we look at functional teat number, not just teat count. There's a lot of data that people want to see, we want to increase our total number of teats, all this stuff. The theory behind it is the more teats the pig has, the more babies she can raise, which in theory works really well. But in the last about 5 to 10 years, there's been a lot of studies that have shown the total number of teat count. If you increase that, you're also increasing the number of non-functional teats, which is not what we want to do. We want to increase the number of teats that can actually make milk and raise a baby. So we look at specifically the number of functional teats on a sow, and that does involve actually stripping milk out of every teat when she farrows. So our staff does actually have to milk a pig very little. And that is something that brings me a little bit of joy because I think it's very funny because they love to send me videos of it. But it's very, very important for our program because as you can tell, obviously we want the most number of babies born alive at weaning and that make it to the end of production. Yeah, go ahead.
Test all teats or just the ones that are?
We test them all. We test them all. So we count when they're a baby, how many teats does she physically have? And then there's a cutoff limit to know bringing her back into the herd, she has to have a minimum number. And then we go from there and actually count how many of them are functional. So she might have 15 or 16 teats coming into farrowing, but when she farrows, maybe only 12 or 14 actually work. So we want to know where. And when we get to projects, I'm also looking at where in her body are they non-functional teats to kind of look at that side of things. Okay, weaning to end of test. This is exclusively growth data. We take a weight at about 65 kilos, which is 6 to 7 weeks post-nursery, or approximately 15-ish weeks of age. And then we take an end of test weight, and at the same time we take an ultrasound where we measure back fat, loin depth, and intramuscular fat. That happens about 120-ish kilograms, or about 22-ish weeks of age. That's exclusively measuring growth rate during that period. And then at the same time, we put boars, mostly just Duroc boars, on a feed intake test for 7 weeks. And that's measuring daily feed intake. So we're combining that with weight data and growth data to look at efficiency. And then here, this is my favorite picture, but it's not super easy to see, but that is what an ultrasound looks like of the loin. So the very bottom, you're looking at the ribs, and then you can see the muscle, the fat, and the skin. And then the middle picture is kind of our setup that we walk them through to be able to do that measurement. And then finally, carcass and pork quality. So there is over 20 years of carcass and pork quality data in our database. It is something that is unique to our company. Not many people have this kind of data. It is on both purebred and crossbred animals. So we have this on all 3 of our purebred lines, as well as our commercial pig, which is also pretty cool. We have currently over 22,000 carcasses, and then we get new ones every year. We look at in-plant data, we look at quality data at processing or cut up, and then we also have the on-farm growth and ultrasound, and kind of all together, that's what we look at for our database. So it's split into 2 ways. The first is carcass composition. So like I'd mentioned, the ultrasound, those are 2 live weights live measurements, that we take, back fat and loin depth. This is taken on every single pig in the farm, every pig. It's how we make selection decisions. Doesn't matter if they're a boar, a gilt, if they've been chemically castrated, they still get a measurement. It doesn't matter what breed they are. Every pig goes through this system. It's pretty cool. And then on the actual carcass, we have hot carcass weight and then the back fat and loin depth of the carcass. This is going to be on a subset of those animals. Of course, a bunch get selected back to the farm for breeding purposes. Some just go for slaughter. Some get sold to other people for breeding purposes, and then a subset will go for carcass measurements. For pork quality, we have 1 live animal weight or measurement, that we take. It's intramuscular fat, also done with ultrasound. That's done at the same time as your other ultrasound data. And then we have marbling, score, loin color, and loin pH at 24 hours. And that's taken on those carcasses as measurements of quality. We'll talk about a lot more quality when I get into the research side. This is very basic quality measures. As I have since learned in the last couple of years, it gets much more involved than this. And then we're going to talk a little bit about the genomic evaluation. So basically what happens is all of that data, that's just the tip of the iceberg to then what we actually do with it and how we select pigs on it. And there's pictures of cute baby pigs. The older ones are much less cute. There's much fewer photos of them. So this is a large but hopefully logical schematic of basically how we do it, what the computer flow looks like. It's extremely simplified. If people have questions, ask Erin about how complicated it is. We've spent the last few months learning that together. But essentially what happens is all the data I just talked about, that's in the nucleus herd. So that's what you see in the top: sow reproduction, meat quality, performance testing. All of those pigs, those phenotypes come into our phenotype database. They all also have a known pedigree. All the parents are recorded, all the pigs are individually identified. That goes into our pedigree database, and every single pig on our nucleus farm is genotyped. Everybody in our breeding herd. So that's in our database as well. We also have multiplier and commercial farms. Some have genotyped animals, some don't. Some collect some of this data that I've talked about, others collect other parts of the data. So those all kind of flow together into the phenotype database and the genomic database. On our multiplier farms, we know the parents of those animals. On the commercial herds, not so much. Those are identified by their genotype. We're able to track their parentage back. So our pedigree database ends up getting modified just a little bit based on genomics. So we're going to be using genotypes to verify parentage, or in the case of our commercial pigs, figure out who either parents or great-grandparents, grandparents are. So we can combine that data. All of that, our pedigrees, our genomic database, our pedigree, the modified pedigree, all comes into our system. We use a single-step GBLEP for our evaluation. This is run every single week. We get new data every week. We're running new breeding values every week, and we're updating that to our customers and to ourselves every week so that we always have the most up-to-date, most accurate selection data when it comes time to picking our pigs. You can. Absolutely, Flavio. Mm-hmm.
For litter selection.
Both. So boars are genotyped. We select, it depends on the litter, anywhere from 1 to 5 boars per litter to be genotyped. So then we do a selection stage when they're in nursery to castrate. based on within litter data. And then the gilts will be genotyped when they come back into the herd, mostly for cost reasons.
But you don't have a low density panel to genotype piglets?
We could, it's the cost side of it. It's mostly, it's a cost benefit at this point in terms of they're genotyped with 60K right now. So something from every litter is genotyped so we can verify parentage, of course. And then sometimes we'll do a couple extras to sort of get a better idea, mostly on the boar candidates within a litter, who are the best ones to stay. And it's obviously, it's a little bit more relevant for the maternal breeds because they don't express anything till later in life, where some of the Durocs, you can see growth patterns through performance testing. But yeah, so 2 stages. In the ideal world, everything would get genotyped, but
Yeah.
I don't have an unlimited budget, unfortunately. So I have to pick and choose with what I have.
Thanks.
No problem. So I'm going to talk a little bit about our maternal and our paternal EBVs, and then I'll talk about the selection indexes. And I'm hoping most people here have gone through some sort of a selection index course, so I don't have to really explain too much about that, but if not, I can answer questions. So when we look at our maternal EBVs, something that's important to notice is that every single EBV that you see will not be part of the selection index, right? Some of them are indicator traits for us, some of them are just correlated traits. But the big 3 in maternals are total number born, pre-weaning mortality, and litter weaning weight. These, if you have nothing else, you have to have these 3 things in the maternal side. We also, like I'd mentioned, we look at average daily feed intake and lactation. Other things like wean to service interval. So how long between the weaning are we able to get them bred and pregnant? We want that to be less than a week, generally speaking. We'll wean them, and within 5 days, they should be being bred again. Age at first farrowing, very similar to the dairy trait. We want to get them down to be as young as possible, right, for production efficiency. And that's a lot of that's based on growth because pigs come into heat or sexual maturity based on weight, not based on age. Number of functional teats at farrowing I've talked about. The sow, back fat, loin, and weight loss I've sort of alluded to. We look at how many pigs are alive at 24 hours. Again, most piglet death happens in the first 24 hours of life. Stuff that is just not meant to survive doesn't survive then. Generally, everything after that, sometimes they starve, but more than likely their mom lays on them. So things that are more in the genetic control under the piglets, you're going to see in that first day of life. The rest of it's kind of up to mom. And that kind of brings me to why we look at the number of pigs born alive that are less than a kilogram. Most people would think we want to know what's born bigger than a kilogram. We've kind of flipped it. Our goal is not to make litter sizes, weights bigger. It's to take those small pigs. Generally, if it's less than a kilo, it doesn't survive. So we want to take those small pigs and bring them up to be a kilo or above. And we don't really want those big pigs that are born, 1.5 or more kilos to get much bigger. Once they start getting much bigger, the sow has a really hard time actually delivering those babies. They can get stuck. You can have stillborns, that kind of stuff. We don't want that. So it's more to try to unify the uniformity for the litter as opposed to just bringing all the weight up. So that's why we look at the number of pigs less than a kilo. And then we look at gestation length. Gestation length's not going to change a whole lot. That's a biological limit, as with any mammal, but it is something we monitor because we don't want it to get too long on our pigs. The longer they go, the higher a chance for the piglets to be too big and the stillborns to happen. Paternal EBVs almost exclusively are going to deal with growth, feed efficiency, and meat quality. So you can kind of see where I'm going when I start talking about the different breeds that we use. But age at 120 kilograms is kind of our biggest trait, right? That is how fast can a pig grow to 120 kilos. After that, they're going to be going for slaughter. So how long does it take to reach slaughter weight, more or less? Feed intake and finishing is a big one. The carcass traits I've sort of touched on already with fat depth, loin depth, hot carcass weight, marbling. We look at average daily gain as well, kind of ties in with the age at 120 and the average daily feed intake. We also take that age at mid-test at 65 kilos. That's a really good indicator of growth from sort of through the nursery to that point. And then the rest of these are some of the quality traits or the in-pig traits that we've already talked about. So now we get in the fun parts. This is what I find fun. This is the indexes. So all of our breeds have their own index. It's very much breed specific, but the maternal index traits are exactly the same between the two breeds. So you'll see the same traits listed for the Landrace and the York. So I'll talk about it here and then we'll just briefly look at it for the Yorks. It's just going to be how they're weighted is different. So our indexes are based on an economic model, and the economic model is the profit for a sow that makes it through 5 babies, 5 parodies, okay? That is the minimum that we want a production sow to make, so that's what we've done. As you can see, what I kind of talked about was the big 3: total number born, pre-weaning mortality, litter weaning weight. That makes up the bulk of this index, right? That's where our main priority is. Then what's unique with us, and not a lot of other people do this, is we actually have carcass quality and carcass, like our animal growth traits in our index. So we look at things like how long does it take this pig to get to market weight? What is the fat? What's the marbling? That kind of stuff. Because ultimately, when we're breeding the pigs at the nucleus level, we have to be thinking about what that commercial product is going to be multiple steps down the line, right? And everything that we do at the top of the pyramid will end up trickling down to the commercial production eventually. So we want to make sure that because we promote a product that is a high quality eating experience, we need to be making sure that all 3 of our lines have some sort of pork quality aspect in their index. Are we going to make crazy genetic progress on the maternal lines? No, and that's not the goal. But the goal is that we are making some kind of progress. So the arrows, that just shows you what direction we want the trait to go, up or down. And the numbers is the relative weight or the relative emphasis as a percentage for each of the traits. And if people have very specific questions about the traits, I can talk about it when I don't have a mic on me. Sort of the way that works. And this is what the genetic trend looks like. So what's something kind of cool, and I got the really big pleasure of being there when it got introduced, was these indexes for the maternals, they got introduced in 2022. So they're relatively new for us. We're through about a generation with them, generation and a bit. So what for me has been very cool is I started in 2022 with Genesis, and I have got to see from the day of implementation, I have actually got to now pick the pigs. They're the daughters of the pigs I originally bred have come through the program, and I am physically seeing that change in them. And that's really, really cool. So you can kind of see that's why our pre-22 looks a little funky, but those pigs were selected on a different program. And then since then, it kind of goes up pretty steadily year over year. Keep in mind, this is on a genetic nucleus, because this is a very highly selected population. I'm going to start calling it that, Flavio. I like that. I like that. For this farm, very specifically, yes, because I've been their Genesis since then. So I'm going to call it that. York's is very similar, right? All the same traits, but you can tell pretty big difference in the pie graph. So when we did this, we were looking at, what does each breed actually need a lot of help in? Where are they now? Where do we want them to go, right? So while it is based on a profit model, there's a little bit of like restricted selection stuff that's happening, right? Some desired gains as well. We have goals that we need to meet. So it's based on a profit model with some tweaking. But here you can see the biggest difference is going to be the age at 120 kilos, right? This is a lot bigger portion of the pie than the landrace was. And that is because landrace grow faster than Yorkshires. So we need to be pushing the Yorks to grow a little bit faster, or at least that's in our population. Everything else is exactly what I talked about. All the traits are the same. The direction is the same, everything else. And we've had fairly similar genetic trends in terms of the way they go. Fairly similar. The Kerry effect. I like it. I like it. But same idea, right? Was implemented in 2022, and it's slowly on the rise. But as I say, pig generation intervals at just around 2-ish years. So it takes, now we're starting to see the effects of it. And then we're going to switch total gears to the terminal line. So the Jersey Red Duroc Paternal Index, this is what we use to select all of our terminal line on. Very different, right? Pretty much focused on feed efficiency, feed intake, and carcass quality. That's exclusively what we're looking at. Mothering ability for the Durocs doesn't really matter for us, right? Because ultimately in the commercial pig, that F1 female, the York Landrace cross, that's what we're going to end up seeing. So again, the arrows just showing you the direction. The number in the graph or in the table or on the graph is showing you the relative weight or emphasis on the trait. This is also based on an economic model. But again, some of it with economic model with some caveats, because there is a level of genetic gain in each trait that we're looking to see kind of year over year. This was implemented long before my time at the company, and as you can see, has done very well. Year over year, they're making great genetic progress. It's helpful when you have a good pig to work with, but They've done very, very well with this index. I can't call this one the Kerry effect. This was before me. Okay. I like this. And then the last index I'm going to talk about is called a lean yield index. We actually do not select pigs on this, which is why you're probably all sitting there going, then why do you have it? This is for a lot of our clients that are in various international markets where fat on pigs, they don't want to see it. Their customers don't want to see it. The consumers don't want to see it. And they don't generally care all that much about quality. Could be for varying reasons. A lot of it is due to socioeconomics. They don't necessarily have the resources to pay the extra premium for a higher quality cut. Some of it's just a cultural thing. They feel like the fat's a waste of money. They don't want to see it. So what we do is we also rank every one of our pigs based on this, and we do use this specific index to select on client farms. So a bunch of farms that I work with, they do this. A lot of these farms are a fully integrated operation. They run the nucleus, they run the multiplier, and they make commercial pigs. So their ultimate goal is selling a pork product, not necessarily selling genetic stock, which is our goal, right? So they use a slightly different index, and you'll see it's pretty much just on feed efficiency and low fat, right? That's the big three in there, getting them to market faster, keeping the fat down, and making sure that they're getting, they lower their feed intake, right? They're a really efficient pig. So like I said, nothing that we actually sell internally is selected on this. That being said, within a population, as I'm sure most of you know, we have kind of a spread, right? So we do have animals in our Duroc population that rank very, very high for the lean yield index. They're more suited to it. Those go to clients that are looking for stuff like this. The pigs that rank a little higher for quality, they stay in our program because that's what we're going on. And given that we don't select on it, it's done pretty well internally, because it does kind of follow a lot of the same pathways, right? Ultimately, though, most people only really care about, in actual industry, how much money am I going to make from your genetics? This is a question I get every meeting I'm in, every presentation I give. How much money am I going to make? So what I did was I took our profit model and I adjusted for traits where there are absolutely no economic value currently in Canada. So we are not paid for the number of functional teats on a sow. Currently in Canada, we are not paid on marbling or any pork quality traits. And we're not actually paid on average daily gain because that's wrapped up in feed intake for our economic value. So I've removed those from our equation. And then I created a combined profit value based on a commercial breed composition. So it's 50% Duroc, 25% Landrace, 25% Yorkshire. That will be the commercial pig wean that you see. And essentially what I figured out is that year over year, the trend is that we gain about $3 per pig weaned, which sounds like nothing, I realize, when you're used to only having, 1 or 2 animals per year born. In this case, this could be something like a gain of $300,000 or more for a producer, right? They are having tens of thousands of pigs every year go through their system. So an additional $3 a pig, it's a lot of money. And in 10 years, an extra $40 for your pig, that's a lot of money in that world. So this is pretty cool, and I'm pretty proud of it because I came up with it. So this is really the Kerry effect, I guess. But it's pretty cool to be able to see that we're, seeing that kind of trend. And there's a little bit of a plateau, but generally it's been very consistent year over year. So that's neat.
They have in feed efficiency, the index. How you define feed efficiency? The old feed conversion rate?
We don't use feed conversion ratio.
No, okay.
So we essentially hold feed intake constant while pushing down days to 120 kilos. So they will reach maturity faster, but daily eat about the same. So then you're ending up saving on the back end of it where it takes less days to market. And the reason we did it that way, well, twofold. I don't really need to tell Flavio about the problems with ratio traits. He's the one that taught me about ratio traits. But with a ratio, you can't really figure out where you're selecting. But also, if you push down intake too much, the fat deposition doesn't really happen on the pig. So given that kind of our whole purpose is having a slightly fattier product with more intramuscular fat, you want to keep their day-to-day feed about the same. So if we can just get them there faster, that's the definition of feed efficiency we use. Wonderful question, though. Thank you, Flavio. Okay, the research projects. This is the stuff that all the academics like to hear about usually. So I'm going to talk about some previous, some current. I'm going to show you some results. and then go from there. So previous research projects we've done, you guys have seen the terminal sire index. So we did a lot of work to improve the later stage growth efficiency for that. We've investigated some genomic regions and selection strategies for feed efficiency using group intake data. As you can imagine, or if you've worked with the dairy cows up at Elora, individual feed intake, unbelievably expensive. Very, very hard to obtain, right? Even for companies, almost astronomically out of the water. We can't get huge sample sizes year over year. So we've done some work to look at, can we use groups of pigs? Can we group them? Can we use a group intake? Can we genotype? What's sort of the work there? There's some promising results. It's not totally done, and it's something that we probably should look some more at. One thing we've done a lot of work on is estimating purebred and crossbred genetic parameters for reproductive and carcass traits, which kind of filters into one of our ongoing research projects. I talked a little bit about the maternal indexes, so we've optimized those for profitable performance. And then we are looking at resiliency indicators based on feed intake in high health herds. So one thing I haven't really touched on is resiliency in pigs. It can be defined kind of however you want to define it. I look at it as a pig's ability to get sick and recover, and for its production to then not be inhibited by the sickness or the challenge. That is extremely, extremely hard to do on a high health herd where we don't want the pigs to be sick ever, right? They are not introduced to pathogens. It's just not a thing. So we've been looking at other ways that we could maybe look at indicator traits within a high health nucleus situation that would mimic or be able to tell us how resilient that pig is to different challenges. Could be disease, could be friends, social pressures, all kinds of stuff. Did you have a question, Flavio?
No.
Okay, I saw you put your hand up and I was like, I don't know before I go on. Some ongoing research projects. So I'm going to talk quite a bit about the first one, identifying genomic regions for novel primal meat quality traits. This is currently, as you can imagine, a fairly large project that we've been doing now for 4 years, given the whole purpose of our program is to improve meat quality. We are currently working to implement a purebred crossbred evaluation. So like I mentioned, we do have data on our final 3-way cross. We want to be able to bring that information back into our evaluation for the purebreds to help better inform their traits. Can we do a better job of selecting for an ultimate performance on a commercial pig? We are, based on what I just talked about with the resiliency, looking at maybe ways that we can create GBVs for phenotypes linked to that gold standard. So we did a trial a number of years ago where we put pigs into a disease challenged facility and watched what they did, took genotypes, took the data. Now we're looking at ways to maybe create GBVs with other indicator data going forward. Something that's kind of my little pet project that is currently ongoing but slower nowadays is a relationship between number of teats at birth and the functional teats, including the placement of these teats. Where are the non-functional teats? Where, like, are they behind the back leg? Generally, that's where they're non-functional. And are we able to influence how many teats we can bring maybe above in front of the navel so that we can have more functional teats on a pig? And then the other thing we're looking at is developing EBVs for sow longevity. Like I mentioned at the beginning, in a nucleus herd, we don't keep them past 2, at the most 3 parities, and they move on. We're constantly bringing in gilts. We want new genetics, new blood kind of constantly flowing through the system. It's very hard to look at longevity because generally pigs are culled on our farms not for any other reason other than they're a parity 2 and they need to go. Physically, they're fine. So what I want to do is somehow bring in commercial data, other data, and looking at pigs, why are we involuntarily culling them, right? Is it due to, who knows, health reasons, structural reasons, lack of milk, being a bad mom, because some of them are really bad moms. What is the reason why they're not staying in other herds? So, and I think that's really important as an industry. As I said, most commercial producers, they want them there for 5+ parities, right? So I'm going to talk about a little bit more about actual research projects. This is some work that's being done at Iowa State University by Mike. Mike is a PhD student supervised by Dr. Jack Deckers, and he is looking at the causal structure of carcass and meat quality traits in crossbreds. So he's looking at causal relationships between growth and meat quality traits. All the traits are on the side there that he's looking at. He was very nice to put some slides together for me. I am not the expert on this, so I'm gonna do my best to explain what he's done. and hopefully my best to answer questions on it, but we'll see. He is using a data set that we published back in 2020. It has around 900 crossbred pigs. They have a 43K chip that they're genotyped with. And he has said he has the 13 traits. And it would not be a CGIL seminar without at least one genetic model. So here it is. But it's not in the general normal stance. It's in a simplified stance for the presentation. And essentially, what he has done is he has looked at sort of the direct effect is not really the best way to describe it, but a posterior structural coefficient, to my best understanding, is a regression-like direct effect. So essentially, they've estimated it's conditional on the random genetic effects and all the other traits being held constant. And I know Flavio can correct me if I am wrong in any of this, but this is my best understanding of what he's put together. So essentially, we want to look at how other traits are actually influencing a trait of interest beyond just a regular genetic correlation. And the example when I chatted with him that he's really interested in is marbling. So right now, we know intramuscular fat is highly correlated to marbling, right? That is what we use as our indicator trait. He kind of wanted to quantify what that looks like. So we expect if we increase IMF or intramuscular fat, we're going to increase marbling. And that is true. But what he has found is that he could quantify what those here and here, what those pathways look like. He can sort of tell you exactly, predict how much unit change you're going to see in marbling based on a unit change in IMF. And he also was able to quantify the fat depth, how much fat depth actually plays on marbling. It's something that was sort of known in the industry. If you reduce back fat, you reduce marbling. But he was able to show exactly how much, and I believe it's 0.9 is what his number was, as a effective correlation, I guess is the best way to put it. So what this sort of allows us to maybe eventually do is change up the way we select or use indicator traits in an index or in a program to ultimately influence the trait we want. And so, yeah, this is work that's ongoing. He still has, I think, 2 years left in his PhD, and he's going to be using some data that I'm going to talk about next as well to sort of, this was his sort of training set, so to speak. He's going to increase his data, try to look at some SNP effects, and I'm going to talk a little bit more about that data set that he'll end up using based on some work that was done with the University of Alberta and a postdoc there, Zoe. This work and 2 other papers have been published. The link is on the screen. So what she did for one of her studies was looking at genetic parameters of correlations for carcass and pork quality traits, heavily with an emphasis on the fat and fat content, fat composition sort of traits. So she used about 1,100 crossbred pigs. These are, all of our data was collected at the Agriculture Agri-Foods Canada Lacombe Research and Development Center out in Alberta. Something that was kind of unique with this project is we genotyped all of these crossbreds using Neogen's SkimSeq pathway, which essentially is a technology that results in an imputed whole genome sequence. Not many people have whole genome sequence on commercial pigs, but it was pretty cool. And I'm not going to lie, it's a lot of work dealing with those data sets, but it's allowed us to kind of look a little bit deeper into something we never would have gotten to otherwise. This work looked at 7 carcass traits. 6 of them were collected using DEXA, which I'll get into in a second, and 15 quality traits on different primals. A lot of her work focused a lot on the belly, which I'm going to skip over a little bit, but that's what she did. Her model is also on the screen, and it's very similar. All the models you'll see are quite similar. But this was the first kind of large-scale project of its kind that I'm aware of. Ooh, I went too far. And as I say, this has been going on for about 5 or 6 years now. So it's been a lot of data. This is the dual energy X-ray absorptiometry machine. So this is what we call DEXA. This is a low dose X-ray that is used to measure composition of carcass. So it can actually differentiate between the lean or the muscle tissue, the bone and the fat, and it gives us a % of the overall image for each of those things. So essentially, one can argue it's a more accurate way of actually learning what the fat content is, the muscle content, and the bone content ultimately of either a carcass side or a different primal. So the top, your left, my right, is a research technician. She's using a probe. That's the traditional way of measuring sort of fat and muscle depth in pigs and marbling, all those different things. And then the picture on your right, You're right. Yes, you're right. That's actually the DEXA machine. So the part that comes up and over, that is the actual X-ray scanner. And then they put the carcass side, or the bottom is all the different primals cut up. The primal under it, they can roll it through or just take a single picture. And then that it does its own little fancy algorithm analysis and essentially gives us the percentages. So a lot of the work we've done is on those percentages using this technology. And I think it's pretty cool. It's not something I'd ever seen before until I worked here. So that was pretty cool. No, this belongs to Canada.
Okay.
Yeah. No.
No, I was surprised.
It's very expensive. Very expensive. We're very lucky to have access to this. That belongs to Canada. Manuel Juarez, if anybody knows Dr. Manuel Juarez. So it's his group at AAFC that's done all of this. He's a huge part of the projects and has been, for my learning on meat quality, absolutely critical, because I worked in maternal dairy traits before I took this job, and I've had a lot of learning to do. So, no, maybe now.
I am asking.
Well,
Changes that.
Yeah, yeah, I can tell you after all the details on that one. It's in progress, kind of, still-ish. We have data. We have a lot of data to go through, so it's good. So these are some of her genetic correlations that Zilray did. This is back fat and IMF, back fat depth and IMF kind of conventionally looked at, with the fat percent traits for the various primals and then total fat. Everything here is pretty much as we expected. The heritabilities for these traits range from 0.22 to 0.55. I didn't show the within percent traits genetic correlations. They're all very high. It's 0.78 to 0.98. Nothing really surprising there. What is interesting, not surprising, but interesting, is that back fat depth is highest correlated with loin fat percent. That's expected, because when you actually look at back fat depth, we look at the loin for that. So I expected that to be high. I thought it would be higher correlated than it is. So what it's telling us is that maybe we're not doing a great job. Maybe there's a better way to select for fat in these varying traits, but also maybe not. It just highlights that back fat depth and IMF aren't giving us the complete picture when it comes to actual fat percentages. That said, though, the good news is no matter what you select on, all the correlations are favorable. So it's all going in the same direction. These are just the genetic correlations for some quality traits. So generally we measure varying things, but fatty acids are a big thing that we look at for quality. Again, not routinely. This is more of a research-based thing, but what we want to have is a balance of saturated and unsaturated fat in a piece of meat to have a good eating experience. And we want to lean a little bit more to monounsaturated fats for high flavor. So what we're seeing, what we also look at is something called iodine value. Basically, the lower the iodine value, the firmer the fat. People like that for processing. It's easier to slice the bacon, but it also makes it very hard. As you can imagine, getting some of this data is very difficult and very expensive. So we also look at the firmness of the belly. Because the firmness of the belly is quite easy to get a belly bend, and that actually gives a lot of information on how much saturated versus unsaturated fat in there. The firmer the belly, the higher the level of saturated fat. Maybe okay for bacon, maybe not great for some of the other eating experiences. That unsaturated fat is the juiciness that you get like when you cut into a steak. So it's just a really interesting way of looking at it, and some correlations that I thought were kind of cool, something that I'd never really seen much of, and helps us sort of when we do some of our selections. Something to think about. And then the last kind of thing I'm going to talk about for R&D is stuff that Erin has done since joining the team in October, where she has looked at some genetic parameters for carcass and primal specific DEXA traits. So she is using a larger version of the data set I just talked about. This is almost 2,500 crossbreds. Same idea in terms of the genotyping and all of that. But for this, we looked at 12 DEXA carcass traits and one sort of conventionally predicted carcass trait. I'm also running out of time, so I'm not going to spend too long on it. And I really won't spend too long on this one. But essentially what she saw, we looked at, within sort of the lean traits, very high correlation, as expected. Within the fat traits, very high correlation, as expected. The lean traits with predicted lean yield. So predicted lean yield is kind of what you see in a slaughter facility. That's the grading probe that measures. That's the like what you get paid on essentially. The predicted lean yield with the DEXA lean traits, highly correlated for sure, not as high as I thought they were going to be. So that kind of tells us maybe predicted lean yield, not the best indicator, maybe a good indicator, but we might be able to do better. For that, heritabilities were from 0.3 to 0.4, so relatively heritable. But I'm not going to talk too much about it because we have submitted this to WCGIL. So if you want to see more, come and visit us. We'll be there. And if you aren't coming, read the paper when it gets published. But to wrap up, we kind of talked about data collection, why it's important, how accurate data really just drives all of this. I will say if you don't have accurate data, you don't have accurate anything else in your system. That is something I have learned. So we spent a large part of our time on data collection. From there, we talked about genomic evaluations. This is used obviously so we can select animals with the most accurate precision we possibly can with the data we have at the time of selection. I talked a little bit about our R&D projects. There's a lot more going on as well, but we always want to be novel tools, novel traits, faster progress. Generally, what I tell people is the stuff that we do today, you're not going to see for 10 years, right? It takes time to get a project done, takes time to get data analyzed, and then ultimately we have to put it in the nucleus, and then you have to see it. So it'll be 10 plus years away. We're always thinking that far ahead, and we want to be cutting edge of industry, right? So we're also always looking at what people want or what we think people want. And then finally, I talked a little bit about the impact, measurable genetic gain and commercial value. At the end of the day, our producers are what pay my paycheck. If we don't have them, I don't have a job. So they're very important. Listening to the people that you work for is very, very important. Getting that feedback is something that I do very, very regularly so that we can make sure that we're ultimately providing a product that people want, people will pay for, and that keeps me employed. So it's all good. What's next for us is, continue to expand phenotyping for things like resiliency, efficiency, and obviously meat quality. We'll continue to always keep refining our models, looking at new traits. As I said, there's quite a few that I didn't even talk about today. And a big thing for us is always accelerating implementation into selection programs. We end up with a lot of research, a lot of data. It takes a long time for that to then end up actually in a selection index. Revamping those is a big task. So that's something that we're working on, sort of pushing forward as we go. And with that, thank you very much. My contact information is there for anybody who eventually does maybe want to talk to me, or I can answer questions for anybody who might have them.
Thank you so much, Dr. Houlahan. I will open the floor to any questions in the room or online. I will get us started. Or did you want?
Know what he's going to ask. No, Kerry, this Duroc line that you have, it's quite different from
Very different.
other Duroc, right?
Very different.
So the origin of this Duroc is different?
The original, not so much.
Not so much.
So Louise did some work on that. He published a paper about 1.5 years ago. So we can actually track these lines back to Durocs that were brought over from, I'm not entirely sure where in Europe, but somewhere, and they ended up in New Jersey. And there's a couple different North American Duroc populations that diverge from that. But the way that we've selected over the past 35 plus years is extremely different than the rest of them. So, I mean, historically, yeah, they kind of all come from the same original population, but that was on the boat during colonialism. So, a long time ago. So there are some similarities, but very different in the end.
One related question then. The other lines of Duroc, they are the incidence of about 10 is high.
High.
Very high.
Yep.
How high is in this?
I have never seen it.
Never seen?
I have not, no. Bob did a project on it a long while ago, and we took pigs to 150 kilos uncastrated and didn't see it. So one project that Manuel had worked on, or sort of has wrapped up now, is like a taste panel essentially on the commercial pigs, light versus heavy slaughter weights. So he slaughtered pigs at about 120, 130 kilos, slaughtered pigs at about 150-ish kilos, and he kept intact boars in some of that. I don't have that data yet, but he said that no difference that they saw, which is really interesting for us because obviously that's a big thing.
Yeah, it could be a big thing in the future. If
Very big.
operation Canada, for instance, eliminate or
Yep. Like we do both mechanical and chemical castrations right now. But like we bring, gosh, how many boars a week would we bring to slaughter? A lot. Probably like 150 to 200 just from one farm. And then the meat side takes that meat from the boars and sells it to the high-end restaurants with no incidence of boar taint, and they're fully intact.
yeah, the other lines, 15 up to 20% sometimes. Depends.
It's 50%.
50. Yeah, there is a, but I mean,
There's a range.
unusual,
There's a range.
like 15,
Yep.
20, but so
It's big.
different.
It's very. They're a very different. They're a very different pig, even just to like look at them. They're very, because they're fattier, right? So they don't have, some of those other Durocs are extremely lean. And so you can see the muscle lines. I mean, as you saw in the picture of the boar, like he's chunky.
Yeah.
Don't get me wrong. There's a lot of muscle in there, but they're just very different. And I mean, I've never had the chance to be in a boar farm with any other company's boars for obvious reasons. But we have a staff member who used to work for a competitor, and he also noticed, and this is incidental information, there's no scientific proof behind it, but he says these boars, the Durocs, are very docile by comparison to the other company's lines he worked with, where then they wouldn't really go in the pens with them. These guys, you can go right on in. Like, they're fine. They'll hang out with you. They're not very aggressive, which is not typical of a Duroc. They're generally, let's put it this way, generally I don't go in the pen with the pigs, as a rule. Definitely not alone. But these guys, they're very easygoing, which is if that's true, as I said, it's very incidental information because it's just one person's observations. But they haven't been selectively bred to be that way. But I promise you, if they're not nice, they're not staying. Nobody wants them around. So maybe it's been a byproduct of some kind of selection.
Yeah, very interesting.
Yeah.
So,
Other
anyone else?
questions?
I'll ask a question. So you mentioned kind of about this, but I just wanted to ask, there tends to be a trend to push away from pork products, right?
Yes.
Kind of leaning towards that now. How does this affect your company with the demand for product? And maybe just clarify, are you selling piglets to the commercial farms, or are you selling actual meat product?
Okay, so I'll do the selling first and then I'll talk about that. We sell both.
Okay.
So my side of the company, I am selling mostly breeding stock. So I'm selling pigs that range anywhere from 50 kilos to breeding weight and age, so that 120 plus kilo range, to customers kind of all over the world. So we ship literally everywhere: Korea, Japan, South America, Europe, you name it. I have watched pigs get on a plane. I didn't know we did that, but we do. We fly live pigs everywhere in the world. That was like the eye-opening moment for me. So that's my sort of side of it. I'm not necessarily selling a commercial pig. Our customers are selling the commercial pigs to other customers. It's an extremely like downstream type of business. When the company was purchased, the new ownership, new leadership wanted to integrate that because they own a packing plant themselves. They own a processing facility. So we've sort of now integrated it. So right now, it's a little tough in terms of demand that I can speak to because the pork can't leave Manitoba because it is not a federally inspected plant. So if you don't know the way that pork sales or any meat sale works, if it's not processed through a federally inspected plant, it can't cross province lines and it can't leave the country. We are a provincially inspected facility. It can only be sold in Manitoba. And because at the moment, we do not have our own commercial pigs that we're producing, that's, future plans down the line, likely. We are just slaughtering purebreds and selling 100% Duroc, mostly meat, to very high-end restaurants in the Winnipeg and Winnipeg greater area. At this stage, we can't meet demand because generally once they have it, they won't take anything else. So we need to increase production, which is a good thing. Speaking on the people wanting to eat pork. So as a industry, I think it's still struggling. I mean, even me who works in the industry, Probably not going to buy pork at the grocery store, not going to lie. I pretty much only eat pork when I go to Winnipeg now because I've been ruined because I get nice, big, chunky Duroc steaks and they're great. But most people are going to, like, if you're going to spend the money, you want beef. What I think will be interesting over the next 6, 8, 12 plus months, I mean, I've already seen this, the beef prices are skyrocketing, right? It's a supply and demand issue. Pork prices are maybe a little bit more appealing. I think the challenge the pork industry has as a whole is it's still a very lean product. It's easy to overcook it. It's easy to make it very tough. For some reason, it was marketed to be like chicken. I'm not really sure why. It's really not like chicken. It probably should be better cooked like beef, not like chicken. So demand, I think, is a challenge. I mean, from our perspective, ultimately, I think our product as a pork product won't stay in Canada. I think it'll go overseas. We've had a lot of conversations with people in South America, people in Asia that maybe don't necessarily want to raise the pigs. They want literally see containers full of this pork frozen. So they also have a tendency to pay more for higher quality meat that really in North America, we're not here yet. We are still very much the cheap, cheerful, budget-friendly option. It's the nice way of putting it. So it's difficult. It is very difficult. And it's also very difficult to market it when what you buy in the store, 9 times out of 10, especially in Ontario, is not the product I'm marketing. Right, in Ontario, it's coming from like Conestoga meat packers. They have a very specific payment scheme. So they are penalizing high fat carcasses. So generally producers here don't want to use super high fatty stuff. So we'll see our boar, our Duroc get used, but it'll end up being crossed with a much leaner competitor's female to end up with a product that still does well when it's graded, but maybe has a lot less fat content than our total package kind of brings out. So that's what you're buying. Anything with Conestoga meat packers, that's what you're getting. So it's just a little bit different. And I think it's an industry that will change, but I personally think it won't change in North America right away. I think it's going to be international markets first. And hopefully, if I do talks like this and can convince people that pork's really good, maybe it'll change here. But I think we're a little ways away yet.
Okay. Very interesting. Thank you. And Tim.
There you go.
I also have time if people end up having to log off and there's more questions, like I'm happy to stay.
I have 2 questions.
Yeah.
One, do you get phenotypes back from the farms that you're selling breeding stock to?
Yes.
And are they comparable in quality to what you?
Some farms, yes, some farms, no. To be quite honest, I probably shouldn't say that on a recorded presentation, but oh well. So within what Aaron and I do, not only do we run our main farms, and obviously we're doing research projects like I talked about, I didn't really touch on it, but we provide something called genetic services. And quite honestly, it's probably 50%. Well, it's for sure 50% of Aaron's job. It should be, it was 50% of my job before I took on this role. And every week we're getting phenotypes back. We're giving, selection stuff. Most farms that are under our kind of purview, I would say 85% the phenotypes are good. We specifically have a quality control measure. So every month, every week, we're looking at stuff. I mean, we have data edits, of course, that tosses bad data, but we consistently look on a monthly and a quarterly basis. And if we see a farm's data recording maybe isn't there, that data is we exclude it from our evaluation. So we still keep it in the database. We still can talk with them, of course, about production and ways to improve. But I would say it's for 85%. It's on par. I'd be pretty happy with what we're seeing.
Second question, really quick.
You can add something, absolutely, Erin.
Make sure your mic is. So I joined the team not.
Turn your mic on. No one can hear you.
Just wanted to add, since joining the team in October, one thing I've been really impressed with is the quality of the clients we work with in terms of their interest in actual implementing genetic strategies. Having moved from like beef, sheep, and goats, where it's kind of a struggle to get everyone on board with genetic improvement, the pork producers want to do better. So it's been really refreshing. So that's a little plug for the pork sector.
The pork sector's been good. They're very good. They talk with us every week. We call them, I would say I call like farms all over the world once every couple months, check in. I was in the Philippines last year and physically visited some of our customers. So like we try to be very hands-on as well. And as Aaron said, they want feedback. They genuinely want to do better. And if they don't see improvement, they want to understand the why behind it. They want the science, which dairy was maybe a little bit more like that to an extent, but it's very nice. It's nice to work with farms that want your help.
Another question. Yeah. Make sure your mic is on, please.
Yeah, so within the nucleus herds, how major of a concern is inbreeding and kind of what are the strategies employed?
Good question. So we keep it pretty strict. Nothing above 5% is allowed to stay or be mated. All matings have to be below, we try to make all matings below 5% inbreeding. That's based on the last 5 generations of the pedigree, because obviously with line breeding, I mean, it is what it is. We maintain within each breed a variety of quote lines in the breed. That's generally just family lines. There's no divergence in selection strategy at all, but it is within sort of family lines. And we routinely want to cross those within a breed. So I will say it can be tough sometimes to keep that. Sometimes you got to be really strict. Some farms are better than others at following those directions. But some ways to combat it. So like I say, anything, if there's a mating that was above 5%, nothing from that litter stays. Boars are all of them are castrated. And gilts, we'll go through the performance process with them because the data doesn't hurt, of course, but no gilts will be kept back either. And generally they won't be sold to customers. That's considered kind of a lost litter for us. Then we also, so each week, I'll use one of our herds as a quick example because it's the one I work with every day. So we breed about 20 females a week per breed with that group. I am breeding them to 3 or 4 different boars within that 20 every week. So we have a bit of diversity each week because everything kind of works in weekly groups. So whatever is bred that week ultimately will be those offspring will be what I select in 6 months, or I guess 9 months if they're bred, 9 into 10 months back. So I want to have a diversity of not everybody is a half sibling, right, to come back, because then ultimately those boars and those gilts will reach sexual maturity at the same time and be bred. So we want to keep that. We also have a rule where no boar can be bred to a female with more than 20 times. So as soon as 20 services are up, he's gone. In our system at a nucleus level, that generally means getting shipped to market. In client systems that are integrated kind of down flow, and they're usually integrated on one singular site, it makes it challenging when you move site to site for disease purpose. But if you're on one site, a lot of them, they call them downgrading it. So those boars move from nucleus boars to making production animals. There's not as much genetic turnover. We're not as worried about inbreeding or at all, right, because they're completely crossbred. So that's fine. But those are some of the strategies we use. Inbreeding is really tough. I will say that's one of the tougher things, but we're very lucky that we have such a detailed pedigree that we can go off of, and then we can, try our best to do it. There's always a litter or 2 a week that it happens because that's the semen that they had, right? Genetics and production are balanced. So I don't get my way 100% of the time on the farm. And, if there's one outlier, they're not going to go collect a whole boar and waste all of that for one breeding. It is what it is. And because we're integrated with the processing, for us, it's not a total loss, which is nice. Yeah, go ahead.
My question, you kind of touched on a bit of it there, but I was wondering you manage the nucleus herd and the maternal herd that then goes to, that you sell to the.
I kind of manage them all.
Okay.
So we have the nucleuses in Canada. Let's put it, I manage herds in Canada, the US, the Philippines. I think that's it for right now, right? Canada, US, Philippines. Aaron manages nucleus farms in Europe, Taiwan, and probably will be soon South America.
What's the turnover rate for the sows and boars that you're using to breed in those different?
So the replacement rate for sows is 120%. So like I say, 2 parities and they're kind of gone, which means they're there for about a year.
Okay.
If that kind of gives you so we say the average parities is 2.3 parities a year per sow. Okay. So generally from first breeding to culling is about a year. Boars is like 6 to 8 weeks.
Yeah.
And they're turned over.
Okay.
So it's a 100% replacement rate for boars, but the timeline's pretty quick.
And is that similar for the maternal breeding of the maternal sows and the
Yeah, so that's all nucleus sows. Are you thinking like crossbreds?
the next?
Yeah, multipliers. Multipliers, not as quick of a turnover rate. I would say the goal is still 100% replacement rate. Most multiplier farms, that is not financially a good decision for them. So like one of my multipliers has an 11 parity sow this week.
Wow.
You know, it's great for me because I can boast like she made it to 11 parities. That's pretty phenomenal. And they want to breed her again. Like she's not on the cull list, so that's good. But I would say most of them are there for about 5-ish parities. On the boar side, there we're using semen out of a stud, not internal boars. Again, it doesn't make sense to try to make their own boars. And when you bring pigs into a farm, you have to quarantine them, and most farms are not set up for that. So they use stud boars. We replace stud boars depending on the stud every 4 to 6 months. So depending on the boars, they probably use them for 6 to 12 months.
Mhm.
If the herd, there's a lot of multipliers that do internal replacement, that we try to bring the boars through a little quicker. But they'll still end up using them more than on main nucleus kind of idea. Yeah.
Thank you.
Right.
Yeah, that's the last one.
Right, it is 2:41.
So I'm curious about the Duroc.
Yeah.
So do you do any kind of typing?
No.
To look at translocation?
This would be a great project, Flavio, that we could chat about. Not right now, no. We don't do that at the
Do
moment.
you know, I'm asking because there's some Duroc lines that they have a high incidence of translocation,
Okay.
3-5%,
Oh, interesting. Yeah, it's a lot.
more than the white.
Yep.
So I wonder if this particular line is also.
We could make a project and look at that very easily if you would like. We've never done it. From like an industry perspective, we've never done it, but it'd be interesting.
I don't want to discuss names.
Yeah, of course.
There's some lines that they do, they collect before they use the board, really do karyotype to.
Oh, interesting.
Because most of the translocations that are not beneficial, but there's some translocations that make the board go there, right? Because it's favorable rearrange chromosomes.
Interesting.
Yeah. But
we haven't, but that doesn't mean we won't in the future.
Probably you don't have because you would note some problems with offspring, right? Some
or if we have it, I mean, if it's an issue, depending on what it is, they're probably called out very quickly, right? Like if they're presenting in a phenotype, either the semen's not good for whatever reason, or if we have a lot of, we call them genetic defects that we cull for in farrowing that I didn't really get into, but
maybe we're excluding these things.
there could be some there that just kind of, it might show up, but it never makes it back to the herd kind of thing.
You don't do any sex semen in this case.
No.
Because the same technology that you do sex semen for dairy, you can use the same technology to identify translocation.
Oh, that's interesting. That's really interesting. I don't know that anybody does sex semen in pigs.
Yeah, no, I just.
But that's interesting.
But that technology you could use the semen to try.
Yeah, to check. That's really interesting. I didn't know that. This is why I like coming back. I learn new things. So forever the student.
I will end it here. This was a really great discussion and a great presentation. Thank you for coming and visiting.
You're very welcome.
I will be posting the recording next week, so I'll let you know about that. Thank you everybody for coming. We will see you next week. And for those of you in person, there is coffee and snacks in the back there. So feel free to help yourself.
And that coffee is not old.
That was
for the noon. We had a meeting here.
this morning. Yeah, I think.
Yeah, it's not too old.
Okay.
3 hours.
So there's snacks here, guys.
Yeah.
It might be.
All right. Thank you everyone in line.
Morning.
Take care.
Yeah.
For those of you here, if you have other questions, I will hang out for a little bit. I booked the whole day to come.